What is up, hackers? Zoid, aka Crypto Mux, right here. And in this video, we're going to be talking about how to program a SSRF tool. What this tool is going to basically do, it's going to basically have standard input where you can do subdomain scanning and chain it with the and also chain it with wayback URLs. Or you can just export out the sitemap history in Burp, and you can basically feed it into the SSRF testing tool, and it will test each parameter and inject your own server into each parameter. And if you get a connection or the SSRF hits your server, then that's worth investigating. It's not a vulnerability because remember, SSRF by default could be made by design. It might not be a vulnerability. It's what you do with it is the vulnerability. It's just a test to detect an SSRF. So this is to detect an SSRF vulnerability. So let's just nano. First of all, I'm going to source the profile, and I'm going to nano out, and I'm going to call this program just SSRF tool.go. And this video is for people that know a little bit about Go. So I'm going to type pretty quick just so we can get the tool out. But yeah, here we go. So package main. I'm going to import my modules I need. So FMT. I'm not going to basically have color in this one. Might later on, but not in this one. It's not going to have color. Time and sync for Goroutines. And we're going to have what else do we need? Buff.io for reading standard input, same as that, or to create new scanners and stuff, and then OS is going to be for our standard input. And then we're going to have IO util to read the response body to grep for things, and also the last one will be net HTTP for a network communication. Let's define our function main. This is where the program will begin. And let's also define some flags, which will be used for our arguments passing. So we're going to define a concurrency flag, and this is going to be of type int. We always have concurrency because we always like to use Goroutines because it's very quick. Oh, geez, coffee is good. Okay, int var, because it's a flag, if it's integer var, it's an integer flag, so we use int var. Put the concurrency into the first parameter. Second parameter will just be the name of the flag, which would be C. Default value you can put 30, and we can just put set the concurrency for greater speeds. Okay, the next one will be a string, which would be our server. And lastly, we'll be having the response, so match response or match. So we'll have a matching one. So I have a matching, so we can match what the response is actually, what the response is. Because this will be used later on for like if we have our own payloads, if we want to inject payloads into it. We could basically grep for things in the response. Actually, just by the way, I might actually have a payload list. So I'll call this payloads. And this will be what we're going to do is we're going to basically iterate for all the payloads to be injected into. So the first one is the string var, which is going to be our payloads. So payloads, just put that PL for payload list and be nothing to default. And this is the payloads list. Perfect. So type correctly. Next one is going to be the matching string. So this is what we're going to be used to match the response. So we'll just put that as M and nothing by default. So match the response with a pattern. And we could put like example, and we might want to grep for we might want to grep for example. Or we might want to grep for success for success. And what this success is, it will be like if you put it all as metadata URI in the payload, If it matches with success, it means we can successfully found a SSRF, a full-fledged SSRF. I'm going to sipping coffee throughout this movie because it's morning over here, and I need coffee to be able to work. Okay, so we need to just do some basic checks to see if if the payloads is not equal to nothing, empty string, and the match is not equal to an empty string. And if so, we'll then continue creating a Goroutine. So continue creating the Goroutine. Okay, let's create the Goroutine. So we need a wait group. Okay, that's pretty much the wait group there. Now we need to iterate through all the concurrencies. So we need to have that. It's going to be a integer, and we're going to iterate through from 0 to the number of concurrent threads we're going to have, and we're going to increment by 1. Okay, cool. Just going to clean up a bit. Awesome. Okay, so now we need to add the wait group, and we need to create the Goroutine function. And after this, after the Goroutine, all the Goroutines are finished, we will be, well, actually, after one is finished, we'll wait, and then we'll do the next one, which will be do the next Goroutine. So this will be test SSRF. This is what it's going to be called, the function. And I like to keep my naming conventions underscore, just because I like that naming convention. What we're going to do is we're going to pass in the payloads and the match string. And this is pretty much how you do a Goroutine. Is this chunk of code here, this statement, or this chunk of code is how you do a Goroutine, how I do it in my program. So we create a function, test SSRF, and it's going to pass in the payloads and the match, which is going to be both of type string. So this is used to test for SSRF. Okay, cool. And just remember, I'm not gonna put the match as a requirement. I'm just gonna make the payload list be a requirement, because we might not want to match. We might just want to detect it and hit our own Engrok server or our own Burp Collaborator server. Okay, so I need to sleep for a small amount of time, just so our Goroutines can work. It's going to be 10 milliseconds. We're going to read in standard input first. So we do this by going buff.io new scanner, and we pass in os.standard input. We're going to iterate through all the standard input by using for scanner.scan. Remember, this is actually true if there's something to read, but it's false if there's nothing to read. Then we're going to also need to open up our file to actually be used too. So what I'm going to do is I'm going to look at how to open up a file. Can't quite remember. Just going to open up a new tab here and go read files in Go language. There is actually a way to do it. I just always forget. Reading files in Go language. No, it's not that one. It is this one, I'm pretty sure. Okay, so io-util read file, and it will print out the context of the file. Okay. Pretty simple. Okay, let's do that. So it actually requires a output argument has a two return types, two returns, file and error. And we go io-util read file, and then it will be the payloads file. If the error is an error, then the file could not be read, so we'll put that in. So log, I think it's like fatal, file could not be read, and we need to put in log there too. Awesome. Let's just save this. All right, next step is to basically read the contents of the file. So we need to iterate through line by line. This is how we do it here. So, okay, here we go. So open up the file, check for errors, defer, so remove it from memory, and then scanner. over all that. Okay, let's do that. So let's actually do that. So we're going to open up the file. So os.open the payloads, and I think they called it F. They defer the close. So after the file has been opened, we remove it from memory. There we go. File close. And then we want to basically iterate through each of the payloads. So I want to go call this payload scanner or P scanner, buff new scanner, and we'll go file like so. And then within this scanner, so as we're reading standard input, I'm thinking we maybe append or the link, all the URLs were found to a list. So or we can just do another scanner group, which we might just do. So scan. It's a double for loop, which is can be quite inefficient, but with Goroutines we won't even notice a difference. So with this we'll put our link, and this will be the scanner.text, and this will be our payload, which will be our pscanner.text. And then we just want to basically try and iterate through all the parameters. So TomNomNom has a good tool called QoS replace, which we're going to be basically getting a bit of his code out of it, and which is basically the net. So here we go. So the code that we're going to be using is this one here. We're not going to be we can be encoding the input too. So we're going to basically do this. A bit of code here. Let's just move it off to the side, and let's import net URL, because that's what we need in order for it to work. So we need net URL. Okay, so what we need to do is we need to define a URL that's going to have our parameters replaced with the payload. So we need a QoS we need to get the URL values of the URL. So I'm just trying to think where this is actually at. There should be another. This is okay. So we need URL values. We need to iterate through the parameter and the value, and this is going to be range u.query. So when we need to do now is before we enter into the statement, we need to actually grab the u value, which is going to be the url.parse link.text, and yeah, cool. That's how we do it. Then we're going to have append mode 2. So if append mode, we're going to have append mode 2, which would be useful for, like, you know, for appending to a parameter. So let's put that as well. So let's put as var append mode boolean. And we're also going to put that as a flag. So flag.bool var append mode, put as a. By default, it will be false, but we'll be able to set that. So append the payload to the parameter. Cool. We need to put that into the function too. We need to pass that in append mode, and this will be like, you know, append mode boolean. Awesome. Okay, so if the append mode is actually true, it's kind of this is going to be a different attack, because what we're doing is we're not really iterating through each parameter. Which we need to do, we just basically replacing all parameters with that payload. We can work on that a bit later. I'm going to set the parameter to param. So we're going to set a new value of the parameter, which would be vv0 plus the payload, which would be payload here. Awesome. And then else, if you don't know what you want to append, it will just replace it with the payload. parameter with the payload. Okay, cool. And then we want to URL encode this. So we want to get the raw query, and we want to encode this. Awesome. Now, if we actually do this now, if we actually print out the URL, we'll have all the parameters replaced. Let's have a look at this now. And let's have a look at this. So let's now we don't need that bit of code now. Let's build it. There is some errors. We haven't used IUtil yet. We will use that soon, so we'll just put a comment there. We haven't used HTTP. So just comment that out and go and build. Link.text on line 65 didn't like that. So what we're going to do is we're just going to put the link. Go. So error is not defined, not used at 65. We need to put error. We need to do some error checking. So if error is not equal to nil, meaning there's an error, we'll just continue. We'll just return like so. Okay, so if we just get a single domain, something like twitter.com, and we use wayback URLs and pass it into our SSRF tool, basically it's going to say, oh, sorry about that. It's going to say we're going to actually need to specify a few things, like the payload list. So let's create a payload list, nano payloads, and let's just put in something like, you know, localhost. Okay, and we'll put that in our payload list, and we'll just run that now. Okay, so what's going to happen is it's going to iterate for each parameter, and it's going to replace it with a payload. So let's just see what happens. See what happens. If it's just fetch it with wayback URLs, it should work. Yeah, hopefully it works. Wayback URL is a little bit slow. Let's actually, oh, here we go, now it's working. Let's grep for only parameters, and let's just take it out to a file called urls.txt, just so we can use it directly instead of, like, you know, using a one command, because it can be slow. So let's go look for only parameters, only URLs with parameters. They go awesome. So let's cut out the URLs and use that SSRF tool, and use the payload list. So payloads. We're not really see it now because you can see it's replaced it with the localhost. Everything. That's good. It works. Let's then get our SSRF tool. Let's do some grepping. Let's now send it to let's create a request. We're not going to be using post request. It's just going to be get request. So we'll put our testing over here, and we'll put like testing and then the URL. And then what we're going to do is we're going to have another function that will make a request. So function make request, and we'll pass in the URL as a string. So what we can do now is we can actually go make request. And I just remembered I haven't got the right naming convention here, so let's just put that there. You go make request, and it will be the u.raw. U. And then we're gonna go. We're gonna create a client, which is going to be used. So client http.client. Then we're going to create our request with an error. Our HTTP new request takes on has two return types: request and error. It's going to be always a get. We're going to have the URL here and then the nil body. Okay, cool. And then we're going to client do request. So we're going to make that request. We're going to send the request to the server, and we're going to get a response back, which is also going to have return two types, which is going to be the response and the error. So if the error is not equal to nil, then we'll just return. Same goes with this one here. if the error is not equal to nil, just return. Awesome. We also need to get the body bytes, and we need to read through the response body, and this is going to be used for our grepping, by the way. So response body, we're going to convert this to a string, convert the bytes to a string, which we need that to the proper syntax, and this is going to be used for matching. So we can go if the body, well, actually we need to put in strings, so we need to import that. If strings.contains, so if the body string contains the match, the thing we're wrapping for, the pattern I should say, you know, then there could be a vulnerability. Let's just make sure we've got everything set up here. We need strings, and we need this as well. We also need strings. And we also need our match that's going to be put in there, which is match. Cool. We call it match, not pattern, so we'll put match there. So then there is, so if the body string contains the match, then we can basically say, we could say URL is vulnerable. And that will be basically something to test, pretty much. We're not going to print out testing, we're only going to print out the vulnerable. We can actually have it silent too. We could probably put silent mode where, you know, it doesn't like print out testing, you know. So let's do that. Let's go via silent boolean, and we'll put silent mode in there too, which would be really useful. So flag.bool var silent, and we'll put S for silent, and by default it will be true. It will be silent by default. So we can put this print silent, go print out output. Print output basically is what we need to do. So let's put the silent variable in there, the variable into the parameter SSRF, test SSRF. And then we can put that as a boolean too. In this we need to define the silent parameter in our SSRF test SSRF function, and we can go something like this would be pretty cool. If silent is equal to false, then we can print out the testing, things like that. But if it's so, we can actually make it. We can actually set the we can make it the helper in our argument, in our silent argument. We can say only print. We can go only print vulnerable hosts. Which is pretty cool. Okay, cool. That's really sick. It's gonna be a really good program when you use this. Okay, so pretty much that's what it's doing. It's making a request, checking to see. This function is making a request, checking to see, checking output for vulnerabilities. Awesome. Let's save this and let's build it and see what happens, eh? Strings needs to be input there, so it's actually strings, not a string. And what I'm going to do is I'm going to get a okay, so URL. Okay, so we need to what line was that? That was 87. Okay, 87 requires I think it's like a string. I think, I'm not sure. Let's have a look. Not string. HTTP client now. Imported, not used. Oh, okay. Strings. Okay, that worked, but the read all returns 2 values, and the client do is undefined. Okay, cool. I've got this sorted out. Awesome. So we need client do, and I always get confused, but read all returns an error too. So returns 2 values, which is error and bytes and error. Okay, that should all print. That should all compile properly now. Match is undefined, so let's get that match. Match should be here, and we'll put match here. Okay, let's build this. It should work. Awesome. Gonna have a sip of coffee. Coffee is so good. Okay, now we're going to go to there's a blog Medium post where we can actually test for SSRF. If you want to extend this and make it so it checks all the post requests too, that's totally up to you, but I'm not going to do that in this one because it might get a little bit too advanced. Maybe I'll extend this tool, who knows. So let's just have a look at, there's a website here I'm trying to find where it actually shows you a vulnerable SSRF host. It actually might be this one down here. There is one we can test, which is this one right here. So this is actually a live host that's vulnerable, but it's just to practice with. So what we'll do is we'll just we'll copy this. It's actually an SSRF from the path. So we'll add this to the payloads, and we're going to actually use this, test this out. We're going to test out this tool. So we'll grab this and we'll echo out this host, and we'll use our SSRF tool to pass in the payload list, and we'll match success. So as you can see, what I mean by success is this is what we're matching for here, code success. So let's just actually just put that in. And if that's success, if that works, it will say vulnerable, which it didn't, because it hasn't actually injected it into the path as well. We need to inject it into the path. So let's fix that up. Let's go, if we're checking just paths, we can go paths. So if this is checking paths, then we won't test parameters, pretty much. So we need that here. So flag.bovar paths, and we can go p, I guess. It will be initially set to true. Only test SSRF in paths. That's pretty much what we're going to type in. And paths needs to be input into our function. This is one big function. Might have to clean up a bit. Okay, so if paths is true, then we actually don't need to test for these values. So if paths is equal to false, then we'll test. But if it's like it only check the paths, it only test the value parameters if the paths is false. Okay, cool. Let's just put in this here. Actually, no, we could probably put that. Yeah, that needs to be in here too. Okay, let's do that. Let's make request. Else, if this is actually if we're not testing paths, so else as well, we will just pretty much do this. We're only testing paths. We will append. We will go. We'll go link, and we will append the payload, and we'll call this URL. I will call this new link maybe, and yeah, we'll just go new link, and this will be appended here for here, new link. Now if we actually build this and we make it so we actually by default paths is already in there, so let's check the, okay, nothing happened here. What is, I think I set paths as default, didn't I? Only test processor from paths, which is true. So let's actually fix up the patterns. It's actually not grepping the patterns properly. So so this is actually true, so paths is false. True. New link. Let's just print out okay, now let's print out the link. Let's put silent mode off. So let's go silent false. What's it gonna do? It's not even printing out the hosts. It's not printing out nothing. So silent false. We don't need just trying to think this through. So paths is false. Put that in there. So paths is false. Paths is false, meaning it will test parameters. But else, if it's Let's have a look at this. A silent false. Yeah, it's not printing out the arguments for some reason. The URL for some reason. It's weird. Let's have a look. So path is false, so it shouldn't test for parameters. Let's just print out here fmt.println paths and see what this is giving us. It might actually not be set, maybe. Let's have a look. We'll just analyze this further. So it's true. Okay, so actually, why is paths is true? Yeah, that's paths is true. Okay, paths is false. I should print out false. Okay, so it's actually the path is not being set. We need actually no default value for this. I think that's how you do it. So we'll do a nil default value. Can we do nil? I don't think we can. No, we can't. Okay, so paths is going to be true by default, and silent is going to be true by default. Okay, cool. Okay. It's not setting up my the P and the S. So paths, silent, yep. Parameter, default value, and yeah, that should work. Path silent. Okay. That's strange. And it's saying that paths is false. Or is it true? It's saying it's true all the time. So let's have a look at this again. It's saying it's true, so it should be going there. And it should be printing out the new link, but silent is true. So it's always staying true. It's not updating what we set. So maybe if we save this, and if we just go build, and if we just maybe go 1, so 1, if we go 0, 0. So that is not even coming up, nothing, false, false. So I need to print out the values first. Print ln paths. Let's see if this is working. It's false. So paths is, I set paths to true. That's so false. So it's no. Okay, so it's not updating the the booleans for some reason. Boolvar, intvar. And I printed it after it's been parsed. Yeah, that should work. That's strange. That should work. Let's set this to false. That should be false now. Yep, false. Cool. So that's false. So that should print out the URL now. New link. We should have the payload appended to it. Which is not printing out. This is really strange. Let's get rid of the silent and the path. We need the paths, but yeah, this needs to be fixed. We need to do this. Let's have a look at on Google for this issue. So booleans, Go language, bool flag. Let's have a look at this. The boolean defines a bool flag. Let's have a look at this. So flag.bool flag pass. We need to actually set equals. Okay, let's do that then. That might be why. Let's go equals true, equals false. Now let's see if there we go. Nice, nice. Okay, it works now. Good. We need to set equals. And and it's working. So now it's just the matter of so we need to test in paths, test silent false. Good, we actually are working. We need to set equals. Oh, finally, I need to actually know that. So let's now. It's not actually comparing. It's not actually contain. It's not matching this at all. So let's try and see if this is true. So if it finds this match in a response, it should actually work. But let's actually first of all print out the body string, because I've got a feeling that it's actually not going to print out the right body. Okay, let's do this. Yes, the authorization required, because we need to put proxy there. That's why, and then that should work hopefully. And what I'm going to do is I'm going to put silent equals to true, and it should say vulnerable. Nope, I didn't. Okay, so just wait a minute. Now it should print out vulnerable. Success! Awesome, it's vulnerable. Awesome, it worked. Our SSRF tool is going to be awesome. Let's just print out, let's just get rid of the body. And we're going to actually print this out when it actually finds something. This should be really cool. Alrighty. I think that is pretty much it for the SSRF tool. This is pretty cool. Okay, so let's have a look at it again. It's printing out all the, it's actually testing out all the payloads, and it finds a successful vulnerable one. This is pretty much how it's going to work in a nutshell. I'm going to be working on it a bit more, and it will be on GitHub. And yeah, just you know, don't forget to like, comment, and subscribe. You know, I work hard on these videos. You can join my Patreon page, which is I'll just show you that now. So Patreon is I have like Patreon, and I teach all, you know, hacking and, you know, release my tools. You got a VIP Patreon where you get mentoring, $10 a month, $5 is a premium Patreon, which you get all access to my private tools and research and private posts. $2 a month for just the techniques and just the hidden, like you can unlock hidden posts. So yeah, thanks for watching this video. This went for a while, but you know, enjoy this tool and try and find some good vulnerabilities.